Welcome back, everybody. Mr. Allen here. I just thought for today I'd go through some of these practice problems from the first day's problem set, and it would just kind of give us an idea of kind of the thinking as we walk through these questions. The answers are posted, but sort of the development of the questions is much more important than the actual answer. So here, the first one I have the word red coats. There are 8 letters here. And essentially, I'm going to be arranging them in different ways to form different combinations of words, different sets of words. And essentially, I'm going to be rearranging them to create different sets of words. So in the first case, no restrictions at all. Of course, that means that I have, if we just sort of think it through, 8 possible first letters. Once one of those letters is used up, then I have 7 possibilities for the second letter, 6 for the third, and so on, all the way down to the final letter, which would just be whatever's left over at that point. And of course, 8 times 7 times all the way down to 1 is 8 factorial. I'm not going to punch all these into the calculator. I'll save some time that way. If the word must start with a vowel, there are 1, 2, 3 vowels from which to choose. And so I have 3 possibilities for that first letter. Once that first letter has been chosen, all 7 of the other letters could be the second possibility, and then of course the 6th, the 5th, 5, and so on. So the first letter has that restriction of it must be an E, an O, or an A, but after that all the remaining letters, whichever ones happen to be there, are available for each subsequent position, and so it's 3 times 7 factorial. Wow, that was terribly written. My apologies. 8 times 7 factorial, whatever that ends up being. And in case you don't know, I just typed permutation calculator onto into Google here, and I came up with one just online. So if you ever happen to not have your calculator with you, 7, 3, calculate, and it gives you that there's 210 there. Okay, so again, I'll assume that the calculator work can be done pretty easily and won't go through it for most of the questions, but we'll just kind of set them up that the way I come up with my factorials is by thinking through the problem. And then if I happen to recognize that there's a factorial as a result of my thought process, then I use that button. I think sometimes people sort of assume because they've seen this new math operation that they need to use it in every question. And of course, that's not the case at all. It's only if it happens to come up that I have an 8 times a 7 times 6 all the way down to a 1, then I'll make use of it. In this case, I had 3 times, but the rest of it was a factorial, so I'll use it as well. So, similar thought process here. If it must start with a consonant, then there are 1, 2, 3, 4, 5 first possibilities. And then the rest of the question should be the same as the previous one. And so it's a 7 times 6 times 5 all the way down to the 1. If the second, fifth, and 7 letters must be the vowels, then I'm almost going to write this out as sort of in a penciled form. So I've got my first letter, my second, third, fourth, fifth, sixth, seventh, and 8th letter. And these specific ones must be the vowels. So there would be 3 possible ways to fill in this spot. I could randomly choose the E, the O, or the A. Once I've done that, 3, 4, 5, this position will only have 2 possibilities left, and then the 7th letter will be something with which we're stuck. So I've used up 2 of them here and here, and then obviously this is the remaining vowel. The remaining vowel. The other letters then, because I have to use those in those spots, I'm only going to have 5 possibilities for this one. I'll have 4 possibilities remaining for this one, 3 for this one, 2 for this one, and 1 for this one. And so I have 5 times 3 times 4 times 3 times 2 times 2 times 1 times 1. If I wanted to sort of work that out in some way sort of using factorials, then I guess looking at the purples, I have 5 factorial, times looking at the blues, I have another 3 factorial. But I can also just pick up the calculator and hit 5 times 3 times 4, and so on. If it must start with a vowel and end with a consonant, okay, so it's again, same sort of logic that I'm going through with these other ones. Starting with a vowel means I'm going to have 3 possibilities for that first letter. I'm going to have 5 possibilities for the final letter. And then once I've sort of established those 2 values, I have 6 letters that remain. And then I have 5, 4, and I'm going to run out of room. And I'm not writing very neatly either. So I'm going to have 2, 3, 4, 5, 6, 7, and 8. As we said, 8 has the 5 possibilities, and so I'm going to have a 6 times a 5 times a 4, and I didn't leave myself enough room again. But hopefully you can see kind of what's happening in here. These letters are just kind of any 6 arrangements basically, and so there's a 6 factorial there. I had the 3 out front, and I had the 5 for the final letter, and so whatever that works out to be. And I will go ahead and finish these ones up, I guess, and then we'll try a couple from 2 and 3. If the smaller word red must appear in the arrangement. Okay, so that's a nice one. Essentially what we do then is we kind of think of red as a block. It's no longer 3 different letters, it's a word. It's taking up the spot of 3 letters, but it's taking them up all together. And so basically then, I've got red, and I've got C, O, A, T, and S. So I've got 1, 2, 3, 4, 5, 6 different objects that need to be arranged. And since there is no other restriction, I can basically think of that as just 6 things to place in any order, or 6 factorial. Again, I have 6 possibilities for that first spot, then 5 that remain, then 4, then 3, then 2, then 1. And once I've thought that through, I realize, okay, so that's just the same as 6 factorial. Again, don't want to jump to 6 factorial until I've thought through the problem in the elongated form, and then I realize, okay, so now I can just use 6 factorial on the calculator. But 6 factorial is just kind of what goes on the calculator again, just like up here. I thought through this whole process. I found that there was a 5 factorial and a 3 factorial. And so that's how I punch it into the calculator, but my thought process doesn't jump to factorials until I've established that. And then G is suggesting that we can't have all 3 vowels together. Any 2 together is fine, but we just can't have a situation where we have O, A, and E, or E, O, A, or A, E, O, or those sorts of combinations. And so if we think about these 3 letters being together, sort of ignoring the rest of the problem, there would be, if I'm looking for arrangements of these 3 letters, I could choose any one of the 3 letters to be the first letter, then any one of the remaining 2 letters to be the second letter, and then of course whatever the third letter is, it would just be there. And so there are 6 possibilities there, or 6 possible ways where those letters could be in some arrangement of the 3 of them together. Now, sorry, I didn't say it, but what I'm doing is I'm looking at the situation that I don't want here. And because at the very beginning of the question, I established all the possibilities with no restrictions, if I can find those possibilities that basically I don't want, I can remove them from the group as a whole. And so there are 6 possible ways to arrange these things. And then if I think about how many possible ways can I go about putting 3 letters into this grouping, we've kind of done that before. So in the same way that R, E, and D being together can give us 6 factorial possibilities, well, E, O, A being together can give us 6 possibilities as well. Sorry, 6 factorial possibilities as well. But then there are 6 groupings of E, O, and A as well. So the bad is 6 times 6 factorial. Okay, so again, we'll try that. We found before that when we put 3 letters together and rearrange those 3 letters, there are 6 factorial possibilities. So for EOA specifically, there would be 6 factorial groups of letters that have E, O, and A together. But there are also the possibilities of having AEO, AOE, OAE, and OEA, and EOEAO. So there are 6 different groupings here that could have been rearranged throughout the various letters that we didn't want. So there's 6 bad groups, each of which can be arranged in 6 factorial different ways. It looks like 4320. And so the number of arrangements that we actually are happy with, so the good arrangements would be that 8 factorial from above, which I see is something like 40,320, minus the bad arrangements here, which gives us just about 36,000 even, it looks like, if the numbers on the page are correct. Okay. So again, obviously the toughest one here by a fair bit, but based on what we had done before, we can figure out sort of how many different ways any one specific group of 3 letters could appear in the arrangement, and then recognize that there's actually 6 times that many bad arrangements, though, because these letters could be in any order. So the first annual run, there are 10 racers. How many different finishes can there be? Okay, so fairly straightforward one, I think, if you just kind of picture it as the runners are lining up at the end or crossing the line at the end. There are 10 different possible first place finishers times 9 possible second place finishers all the way down the line, and at the end, of course, there'll be that one guy who comes in last. And so that one should be fairly straightforward, 10 factorial, because I saw 10 times 9 times all the way through. If there are only 10 racers, how many ways can first, second, and third be determined? Okay, so basically now I've got 10 times 9 times 8. None of the other positions actually matter, though. So once I have just those 3 positions, that is going to be my answer. So that would be 720. With the permutation specifically, that's saying take 10 people and permute 3 of them. So this calculation, 10p3 on your calculator, does this same thing. It's take 10, make arrangements of 3 out of that group, and how many possibilities are you going to get? So again, recognize that this is just finding me how many, what is the number of different possibilities we have. It is the same as this. So this is the logic behind it, and that's how that happens to work out. That means take 10 and make, starting with 10, make arrangements of 3. If in the second year there are 20 racers, how many ways can, so same logic, of course, 20p3, or if you just want to think it through, there's 20 possible first place finishers, then 19 different people left for second, 18 left for third. And we're going to advance 20. Okay, so 30p 20 becomes the answer. There are 30 to start. We're going to permute 20 of them. So we're going to randomly pick some 20 and put them in some kind of order, which if you were to think it through, is the same as saying, well, there's 30 possibilities for that first place finisher, then 29 for the second, then 28 for the third, and kind of continue that all the way down to those first 20 spots where I guess there would be 11 possibilities for the 20th person. And you can sort of see that that's getting pretty messy to punch into a calculator. So if you understand what the permutation notation means, you can save yourself some work that way. So the video is running long. I'm going to stop there, but hopefully just kind of talking through some of those first ones will keep you moving forward for today.